Good day, class. So today we are just going to look at things that you need to understand in terms of Euclidean geometry that you need to be prepared for, okay, and understand terms and also things that you need to prove as well in Euclidean geometry. Okay, so today we're just going to be looking at lines, triangles, and also angles, okay. So what we have to know is that a straight line is actually 180. A straight line is 180. So what we see here, angle below 90 is acute, above 90 but below 180 is obtuse angle, and that's your straight line. So angle with a triangle with the right with the 90 degrees angle inside it is called a right angled triangle. Then revolution, so angle at a point, so if we are to have this, so the revolution is 360. The angle at a point is actually 360. That's the revolutions. Now, complementary angles. Now, complementary angles, they add up to 90. So, for example, here, when we have a right angle triangle, we know that the other two angles, they need to add up to what called 90. So they are complementary. Then supplementary angles, they do add up to 180. So like on a straight line, what you need to know, if one part of it is x, then the other part you can get it by saying 180 minus x. For example, here, if it's 150, then the remaining part will be actually, 30. So 150 plus 30, we call these supplementary angles because they do add up to 180. Then what we call adjacent angles now, adjacent angles, they do have a common vertex and also a common arm. So what we're referring to common arm and the vertex is this. So they're starting from from the same point here. Then what we need to understand here is that we have, for example, adjacent supplementary angles in a straight line. Then also on right angle, we have also adjacent complementary. So they do add up to 180 and they are adjacent to each other. Then we move on to lines. So if two lines cross we have a transverse line that cuts two lines here. What we have here, we're going to talk about corresponding angles, alternate angles, and co-interior angles. Okay, so what we need to understand here, when we talk of corresponding angles, these are your A and E. So corresponding angles, that's how you see your corresponding angles. So they have to be two lines with one common line that cuts through them. Then B and F are also corresponding. C and G are also corresponding. Then D and H, we refer them to as corresponding angles. But now let's talk of alternate angles. These are Z angles. They form a Z shape or N. So what we have here is this. Then we've got C and F, they are corresponding, they are alternate angles. Then also D and E, they are also corresponding, alternate angles. Then let's talk of co-interior angles. What are these co-interior angles? They are those interior angles, they do these are what we refer to as co-interior angles, in respect of the property that we're going to talk about. Now, these are what we refer to co-interior angles, C and E, and also D and F. Then vertical opposite angles, these are angles that are opposite to each other, B and C, A and D. Then we also have E and H, and also F and G. Okay, these are vertically opposite angles. And we know that we need to understand that the vertical opposite angles, irrespective of the lines, they are equal. Now, let's now come to what we call to parallel lines. Okay, we have different types of lines that you need to understand. We have what we call parallel lines. Parallel lines, you will encounter more of parallel lines, and you need to apply these what we call a condition that comes with what we call parallel lines. So, for example, here we need to understand that when two lines are parallel, we're saying these lines never meet. So they never meet. Lines that never meet. So these are lines that never meet. And we are saying if they have a common line again crossing them, remember what we spoke about? We spoke about the corresponding angles. We have corresponding angles B and F, A and E, C and G and D and H. These ones will be equal. if the lines are parallel, these angles will be equal. So that's what you need to understand there. So you need to apply that when you're actually trying to find the angles. Whenever you see parallel lines, guys, even in a circle, please just remember the properties of parallel lines. The property of parallel lines, look for corresponding angles, look for alternate angles as well. Alternate angles, we know that C and F, those will be equal. D and E, those also will be equal. So look for those and you won't have a problem. Then another thing again is actually the third part here, the co-interior angles are supplementary. So co-interior angles, these co-interior angles that we just learned about, these ones should add up to 180 if only these two are parallel lines. So this applies only to parallel lines. So as you can check, if you check here, what we have here, we can see that C and G, they are not, these two lines are not parallel. And if they are not parallel, we can't say A is equal to E. We can't say that because these two lines are not parallel. So it only applies to parallel lines, okay? So then area of a triangle, this is just something that you need to know, is base, what we call half base times height. Okay, let's look into triangles now. We need to understand that sum of interior angles, sum of all interior angles, they add up to 180. So we are saying if we take this angle, we take this angle, we take this angle, we add them together, then we get 180. We get 180. We get 180. Now, then we move on to another thing that you need to understand. Exterior angle of a triangle equal to sum of opposite interior angles. So we are saying this exterior angle here is equal to sum of these two. So when we add these two, we get what called, we get what is it, 1, which is this one, this angle here outside. So for example, let's say we are having a straight line. When we're having a straight line, we know that this one here is maybe, let's say it's 150. Then if it's 150, this is a straight line, it means that the interior angle here should be giving us what? Should be giving us 30. Now, when we get 30, it means that also inside this triangle, we need to have these two must actually add up to 150. That's what we are saying, because interior angle is, if we add the angles, they should give us 180. So we have the total sum, same sum. If we add all these angles, they give us 180. If we add these two angles, they must give us 180. So what's missing here is this angle here, and what's missing here are these two angles. So that's why we're saying 150 will be equal to sum of these two angles. So 2 plus 3 will give us actually 150. Okay. So that's gonna say this one here, the sign referred to angle. Okay, so this what called is actually refers to what called to angle. Okay, that's what it means here. Now let's move on. Isosceles triangle. So on isosceles triangle, the base angles, they are equal. Base angles are equal, and also the converse of that, you must know that if the base angles are equal, then you know that the opposite sides also should be equal. So these are the things that you must connect what called when you are dealing with questions what called in Euclidean geometry. Now, another thing again, equality of triangle, we know that equality of triangle, all the sides are equal, and also interior angles, they are equal, or each of them is actually 60. Then Pythagoras theorem, we know that if we have a right angle triangle, this must apply. So b squared, the size of our hypotenuse, should be equals to a squared plus c squared. That's what we are saying here. So it must satisfy this, what is it, this condition, if it's actually a right angle triangle. Okay, let's move on to what is it, to congruent. Now, when I'm talking of congruent triangles, these triangles are of the same shape and actually size. So these triangles, in simpler ways, we can say they are identical. They are identical. But now, if you are to ask to prove that they are congruent, you need to be able to prove one of these. You need to be able to prove one of these conditions. Now, what are these conditions? The first one, we need to know that three sides should be of the same length. So it could be side, side, side. So three sides. So each side here. So we are saying this side should be equal to this side, and this side should be equal to this side. This side, then we can say they are of the same size and shape. Or we can prove that two of the sides of those two triangles are actually equal, and one included angle. One included angle and the two of the sides should be equal. Once we can prove that, then it means that the two triangles are of the same shape and actually size. Then again, you can also prove that two angles and a side, they are equal. So two angles and the side, they should be also equal. We are saying this angle should be equal to this angle should be equal to this angle, and this side should be equal to this side. That's what we're simply saying. Given the two triangles, then we can say it's angle, side, and those two triangles will be congruent. Then the last part is the right angle, hypotenuse, and a side equal. So we must have one, it must be a right angle. Then already we know that the 90 is already equal. Then again, we must have two sides, two hypotenuse, one of them, and one of the sides should be actually equal. Then we can now say those triangles are of the same size and shape. Okay, so let me just introduce you to what we call midpoint theorem. This one also applies to similar triangles. We're just going to be talking about it now. So it says if AB is equal to DB, and also AE is equals to EC, then what we can conclude now from there, sorry about that. So we are saying if AD, okay, is equal to DB and AC is equals to EC, then what we can conclude is that DE will be parallel to BC and DE will be half BC. That's what we can say from there when we see these two what we call satisfying. Now, another thing again, if we see that AD is equals to DB, okay, and also DE is parallel to BC, then we can now say AE will be equal to EC, and also DE will be equal to half BC. So these are things that you apply mostly when you're dealing with what we call Euclidean geometry. And when you see a triangle in the circle, please check there for midpoint theorem, check there for parallel lines. Then you can see whether you can apply this theorem or not. Because once you have that, you can now conclude, let's say you're given these two sides that are equal, and also this side, they are parallel. Then you know that, oh, so AE should be equal to EC, and you will need that in terms of when you're trying to prove whatever the question will be asking you. Then again here, it means that ADE is similar to ABC. Okay, we're just going to be talking about it now. Now, let's look at these similar triangles. Now, when I talk of similar triangles, we are saying those congruent, those identical triangles, what happened to them? One of them is just enlarged. So when we enlarge it, it's not changing its shape. It's not changing its shape, but the size is changing. So we are saying these two triangles, they were same size, but now what do? We enlarge this other triangle. When we enlarge the triangle, the interior angles remains the same. So the size of the angles should remain the same. And another thing, these two sides, all the sides should be in the same proportion. So if we are to grow enlarge our triangle times 2, then it means that this one here will be half this, and this will be half this, and this will also be half this. So that's what we're just trying to say there. So we are saying in that case our triangles will be actually similar. So what do you need to do when they ask you, was this comes mostly what we're to say, prove that the triangles are similar. Now, how do you prove that the triangles are similar? Please, guys, must know that you have to prove one of these two properties, okay? One of these two properties. You don't need to prove everything. So you need to prove one, and the first one, if they are similar, it means that A is equal to D, which means the angles, they are equal, okay? B is equal to E, and also C is equal to F. C is equal to F. So that means that it's actually they are both similar. So you can take this one, depending on the given information, you can use this one to prove that they are similar, or you can use the signs in terms of proportion. Now, in terms of proportion here, we are saying AB over DE should be equals to BC over EF. It should be equals to AC over DF. That's what we are saying there, if they are similar. So you must be able to prove that. You must prove that those sides are in proportion. Once you do that, it shows that you are you have answered the question. Now let's move on to another sort of just a simple question for you. Now, find the size of side X and Y if triangles are similar. We are already told that they are similar. So if they are similar, what do we know if they are similar? We know that EF is equal to, sorry, EF over, I'm just going to write this in general before I answer. EF over LM is equal to EH over LN is equal to FH over MN. That's what it means. Then now to answer the question now, we want to find the value of X and Y. Now, what we know, we need to take the two sides. So you take the one that if you're looking for, remember the inverse of this. So it means that if we say LM over EF, this also should be equal to LN over EH is equal to also MN over FH. I think what best here, you put the side in question on top. It's going to be easy for you to simplify. So here what it means that we're going to take the side that we want. We're going to use Y. So we're looking for Y first. So we're going to say Y over 75 should be equals to, we are already given the one of the pairs. You're already given one of the pairs. So you equate to that 17 over 69. Then your Y will be equals to 17. We cross multiply 17 over 69 times 75 over 1. So we are multiplying by 75 both sides. So what do we get here is our Y. Our Y, we know that we're going to say 17 over 69 times, sorry, what is it? Times 75. We get, what do we get there? Okay, just check here. Times, all right, Y, okay, times 75. Why are we getting this? But anyway, we are getting Y as 18,48. Or we can just say 42,525 over 23 is going to be equals to 18,478. Okay, that's the size. Then what about X? We are looking for X. We are looking for X. Let me just check something here. 23 divided by, oh, sorry. I made a mistake here. Because it's not supposed to be like that. To EF, all right, we took the wrong sides here. So it's Y over 75 is equal to 23 over 69. 23 over 69. I took the wrong side. So it's 23 over 69. Okay. Okay, so it's gonna be 23 times 75. Then let's put it in our calculator now. This should give us a straight answer. Okay, 69 times 75. So you should be worried as well when you get something that is like with the decimals, we are looking for the size like this. You must worry. You must check whether you are making you consider size what called properly or not. Okay, so these are mistakes that occurs every time in the exam. So when you get what called an answer that is not what we say in commas and everything, please try to check your answers and see, especially if these are dimensions. To find these dimensions, normally you get them as whole numbers. Now let's check up. We want to find X, so we're going to put this side on top. We're going to say X over, what is it here? Over 17 is going to be equals to 69 over 23. Can you see what you're doing? You're putting the 69 on top. Then what do we get there? X is going to be equal to 69 over 23 times 17. Then what do we get? We get 69 over 23 times 17. Then we get 51. So it means that X is 51 units. That's what it means there. Okay. Now let's move on to the last part here, question 2. Now, question 2 is asking us to find also Y and X. So to know what is X, what is Y. But now what we see is that this side here is divided here. So we are told that this is x from this point u to z is x, but u to w is a third of x. So it means that the remaining part here, we can simply say this is 2/3 of x, because it must give us x. When we add 2/3 plus 1/3, we get 1x. So that's what we have here. So this part here is 2/3x. So for us to find the x, we are going to say 2/3 is what we are given. 2/3x is equals to 18. 2/3x is equals to 18, because this part here should be, if we add it to what called to 1/3, it must give us 1x. So if we say 1/3 plus 2/3, we get 1, which is what we have here as x. Then here we're going to say, now to find x, we are going to cross multiply. Okay, x is going to be equals to, we cross multiply 3 times 3/2. Okay, inverse of that, then 18 times 3/2. What do we get? We get 27. So x is equals to 27. So what it means here, to find this side here, we're going to say 1/3 of this, what is it? 27 is actually 1/3. So UW is equal to what? Is equals to 1/3 of 27, which will get 9. Okay, so this is what we have. So we are given already 9 and what is it? And 18. Now we're looking for y, but we know that u v over v w, these are in proportion. So we are told we need to know that if in this case here we use the proportionality theorem, this side, the angle, the triangles u v w is actually similar to u v uy, sorry, uy z. So that those two are similar. Those two are similar triangles. So now we can now say, okay, u over v is equal to what? Over v y is also equal to uw over w, what called z. So here what we're going to say here, we're going to say 9, which we have here, y over 14 is equals to 9 over what is it? Over 18. 9 over 18. So here when we have got 9 over 18 and y, so we're going to say y is going to be equals to 9 over 18 times 14. What do we get there? We're going to get 9 over 18 times 14, which will get 7. So our answer there should be equal to 7. That's how we get to our answer. Okay, so we're going to attempt more questions on what is it, on what you call Euclidean geometry. So this is the first lecture on Euclidean geometry. The second lecture will be looking at quadrilaterals. Then the third one will be looking at cycle geometry. We'll be looking at circles. Then the fourth one will be actually attempting questions connecting everything, the knowledge that we have, what called together, and trying to attempt questions and see what is required of us. Okay, thank you so much. Have a good day.